Hi guys, Mishler Math here again. This time we're talking about solving systems of equations, and we're going to use graphing and substitution. So let's start with graphing, okay? And solving systems by graphing. All right. So let's suppose I have a system here, and the first equation is y equals 2x minus 1, and the second equation is y equals negative x plus 5. Now you can kind of tell here you get 2x and negative x, so one slope is positive, one slope is negative, so it's pretty easy to look at this and say, okay, this line is going uphill, this line is going downhill. But let's take a look at that on a calculator, shall we? Now, we look at the calculator and, sorry, didn't mean to get to it right away. 2x minus 1 is my first equation. When I say systems of equations, I'm talking about obviously two equations on the same plane. And the solution is the point that they intersect, point or points. Remember, solution, the definition of solution, is a set of all values for the variable or variables that makes a statement true. So we want to find a value or a set of values or something like that that make these statements both true. So let's take a quick look at the graph of this. You see where the two intersect? At that point, we have an x and a y value that satisfy both of these equations. In other words, make both of these equations true. Let's take a look at what that means. Second calc, right above trace. Go to intersection, 5, we've done that before, nothing new. And first curve, second curve, guess, I'm just clicking enter, 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 and I get y equals 2, x equals 2, y equals 3. So I can test to see if this is going to work. Start with the first one, okay? Does 3 equal 2 times 2 minus 1, okay? Well, 4 minus 1 is 3, so of course that checks out. And look at the second one. We have, does 3 equal a negative 2 plus 5? Once again, negative 2 plus 5 equals positive 3, so that checks out. So this ordered pair right here is the solution because it makes both of these statements true. Let's try another trying to get this thing to clear. There, I did it. Alright, let's try y equals 2x minus 1 and y equals 2x plus 1. Now, a couple of you have already figured out, look at these slopes. The slopes are exactly the same. And if you paid attention in geometry class, you know that that means that the two lines are parallel. Or if you paid attention in Algebra 2 class at the beginning of the year. But nevertheless, let's take a look at the calculator and see what we get. 2x minus 1. And down here, I'm just going to take, click down here and put a 2 instead of the x, plus 1. And it's not really difficult to figure out what you're going to get. You're going to get two parallel lines. One of them passes through the y-axis at positive 1. One passes through the y-axis at negative 1. They're parallel. So what does that mean? That means, real simply, no solution, because there's no point at which these two lines intersect. Okay? Let's try one more. Hey, I'm getting really good at this. All right, I made it a little bit big. Guess I got a couple fractions here. I got 8 minus 3x over 4, and y equals negative 3/4 x plus 2. Now, first I'm going to do a little tricky stuff here, a little manipulating here. I'm going to say 4y equals, I'm going to take this first one and I'm going to multiply both sides by 4, and that equals 8 minus 3x, and now I'm going to divide by 4 overall. y equals 8 over 4 is 2 minus 3/4 x. If I rearrange that, what do I get? Y equals negative 3/4 x plus 2. Notice the similarity here. So what do I have here? This is the same line, okay? It's the same equation written in two different ways. And so what that tells me is that if I do a little algebra on this one, okay, I change it to this one. And so what that means is that I've got two representations of the exact same line. So I've got basically the line goes on top of itself, okay? I got two lines that are on top of each other. And to make it simple, this is, it has an infinite number of solutions. Infinite solutions. Because every single point on the line is on, every single point is on both lines. Okay, you get what I'm saying? And so I'm going to give you a couple rules here that you're going to go by in this section, or a couple of definitions. We define solutions as consistent or inconsistent. Inconsistent means they're parallel and no solution exists. That's what we mean when we say inconsistent. They're parallel lines, so there are no solutions. Consistent can be either independent, meaning there's one solution, okay? Or they're going to be dependent. And that means there are infinite solutions. So you see, you have two lines here, okay? You got three different possibilities. Either the lines intersect. This is independent. They intersect, and you got one solution. Or they're inconsistent. They're parallel. No solution. Okay? That's inconsistent. Or they're dependent. And dependent simply means they're both on top of one another. Okay? And so they're infinite. Infinite solutions. That's how things work in the coordinate plane with systems of equations. But there's more, as always more. Okay? Let's try one. Let's try to graph and classify, because when I ask you to graph something, I'll probably ask you to put a little dot above the, okay, never mind. Classify. So, the system looks like this. Y equals 3x plus 4. Y equals negative 2x plus 4. The only thing I see in common here is the y-intercept is the same, but the slopes are different, and they're both in slope-intercept form. So it's obvious that they're not the same equation. I can't do a little algebra on this and make it the same equation as that. So let's just get out the calculator and see what we can find with this, okay? And go to y and clear, and 3x plus 4. 3x plus 4. Now, we're going to learn several different ways, negative 2x plus 4. We're going to learn several different ways of solving systems. And the reason we're doing that is because there are different methods that work really well for different types of systems. So let's graph that and see what we get. No big surprise there. I see two lines, and look at the point of intersection. Isn't that interesting? Since they both intersect at the y-axis, since they both intersect the y-axis at 4, then we have the solution is 0, 4. Isn't that amazing? Okay, and so let's plug in a 0 here. X equals 0. Y equals 4. Does that work? Does 4 equals 3 times 0 plus 4? Yeah. Does 4 equal negative 2 times 0 plus 4? Yeah. So that turned out to be a really easy one. Okay? Let's try another system, or another method rather, of solving these things. We're going to use substitution. So solving systems using substitution. This is pure algebra now. We're not going to do graphing on this. And so I've got two equations here. 2x plus y equals 3. And 3x minus 2y equals 8. First thing you notice, these are not in standard, they're not in slope-intercept form. They are in standard form. So let me show you these 3 steps. Number 1, and let's do this. 1, solve one equation for one variable. Write correctly, for heaven's sake. So solve one equation for one variable. And in this case, I'm going to solve this one for y. And that's going to be real easy because I subtract 2x from both sides. And I get y equals negative 2x plus 3. So that makes it easy. And then 2, and this is where it gets its name from. Aha! Substitute the value or for that variable into the other equation. What are we talking about there? Well, here's what I do. I put, instead of y, I put negative 2x plus 3 in there. So watch. 3x minus 2 times negative 2x plus 3 equals 8. And then 3, solve for the other variable. In this case, I'm going to solve for x. So 3x plus negative 2 times negative 2x is plus 4x. Negative 2 times 3 is minus 6. That equals 8. So 3 plus 4 is 7. Oh my goodness, I am so sorry, guys. My hands are all goofy today. So we got 7x minus 6 equals 8. Add 6 to both sides. 7x equals 14, and of course x equals 2. And now we're going to do the fourth step, and this is the last step, and use that value to solve for the other variable. What does that mean? I've got the value for x, so all I have to do is go back to the easy one here, and I got 2 times x plus y equals 3. So can I solve that for y and not use a variable? Sure. 2 times 2 plus y equals 3. Let me give a little more space here. And so 4 plus y equals 3. Subtract 4, and y equals negative 1. So now I have a value for x and a value for y. Now I go back to the original equations. I substitute 2, negative 1. Okay? And since I'm solving here, let me get a different color. So let's substitute 2, negative 1. And I think we do this kind of quickly. We got 2 times 2 is 4, plus a negative 1 is 4 minus 1. That's 3, so that works out. And 2 times 3, or 3 times 2, x equals 2. So 3 times 2 is 6. Minus 2 minus 1, 6. Maybe I messed up here. Negative 2 times negative 1 is positive 2. 3 times 2 is 6 plus 2. Yes, hello, 6 plus 2 equals 8. Sorry about that. So yes, that checks out too. And yeah, once in a while my brain turns old. So take it easy on me. So we're going to try another example real quick here, because I know you guys don't like doing all of this time on my videos, but a lot of stuff to be told here. So, and I do want to do one more, and that is 3x plus y equals 8 and 18x plus 2y equals 4. Again, I'm going to solve this one for y, so subtract 3x from both sides. Y equals negative 3x plus 8, and then substitute the y in here. And I'm going to stop right now because I want you guys to solve this. In fact, I probably will stop the video at this point and ask you what the solution to this is, because I really want you guys to try one before you come into class, okay? And meanwhile, we just got one more thing I want to talk about here, and this is pretty important stuff, because once in a while I get a system with 3 different variables, and 3 variables and 3 equations. So it's x plus y plus z equals 5. And some of you might be freaking out right now, but that's all right. 2x minus 3y plus z equals negative 2. For z equals negative 12. Okay, so I hope you can read that. Well, the first step is pretty obvious here. I'm going to solve for z. Okay, for z equals negative 12, so z equals negative 3, to divide both sides by 4. So we got that one, and so now I'm going to put that into this equation, and I've got x plus y minus 3. Could I just put negative 3 in for z? Equals 5. So x plus y equals 2. Or excuse me, I made a bad mistake there. Same thing you guys do sometimes. Add 3. I was in a hurry. So x plus y equals 8. So solving for y, I get y equals negative x plus 8. Subtract x from both sides. All right. And so once I have that, I do the next step, which is putting it into this equation. And I got 2 times x minus 3 times negative x plus 8 plus z, which is negative 3, equals negative 2. So now I've got just one equation, one variable. And so 2x, negative 3 times negative x is plus 3x. And then positive 8 plus a negative 3 is plus 5. Equals negative 2. 5x equals a negative, let's see if I subtract, that'd be 7, wouldn't it? Subtract 5 from both sides. And so x equals negative 7 over 5. And I will leave it to you guys to solve for y on that one, okay? So now we have x, we have z, and when we solve for y, we will have that. And so we've solved the system of equations, and I'm almost 20 minutes. I'm sorry for the time. I think you needed to cover all this stuff, so thanks for hanging in there with me.